FastMCP 3 implements component versioning through a decorator-based registration system, allowing multiple implementations of the same tool to coexist under a single identifier while maintaining backward compatibility. This versioning mechanism enables API evolution by exposing different tool signatures to clients based on their supported version, with the framework automatically handling version selection and filtering. We're about to examine how version tools are declared using the @MCP tool decorator with explicit version parameters, and how FastMCP manages the registration of these multiple implementations while maintaining the ability to serve different versions to different clients. The code demonstrates the core pattern of versioned component definition and the framework's handling of version metadata. From FastMCP, import FastMCP. MCP equals FastMCP. @MCP, tool version equals 1, 0. Def process data, SDR. Original processing. Return data upper. @MCP, tool version equals 2, 0. Def process data, SDR mode. SDR equals default SDR. Enhanced processing with mode selection. If mode equals reverse. Return data, -1 upper. Return data upper. This code demonstrates FastMCP's version tool pattern, where multiple implementations of the same tool can coexist under a single identifier. The @MCP tool decorator registers two versions of the process: function version 1 with basic string uppercasing, and version 2 that adds a mode parameter for reverse processing. FastMCP automatically handles version selection, exposing the highest version 2 by default while maintaining both implementations. The versioning approach enables API evolution without breaking changes, as clients can continue using the original interface while newer clients access enhanced functionality. This pattern is particularly valuable for maintaining backward compatibility during migrations, where you can deploy new versions alongside legacy implementations. The framework's version comparison follows PEP 440 semantics for proper numeric ordering, ensuring 1.9 sorts before 1.1. A key trade-off is the increased maintenance burden of supporting multiple versions, though FastMCP mitigates this by providing version filtering and discovery mechanisms. The strict requirement to either version all components or none prevents inconsistent filtering behavior, as unversioned components would bypass version filters entirely. This design ensures predictable version resolution while allowing gradual migration paths. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, providing access to the model context protocol framework's core functionality for this code segment. MCP equals FastMCP. Instantiates a FastMCP object and assigns it to the variable MCP. This creates a new instance of the model context protocol framework, which serves as the entry point for registering tools, resources, and prompts. @MCP, tool version equals 1, 0. Decorates the following function as a FastMCP tool with version 1, enabling automatic registration with the specified version identifier. Def process data, SDR. Original processing. Defines a function named process that takes a string parameter data and returns a string. The docstring indicates this is the original processing function, though the implementation isn't shown in this segment. The type annotations specify both the input and output are strings. Return data upper. Returns the uppercase version of the string stored in the variable data. The upper method converts all lowercase characters in the string to uppercase, leaving other characters unchanged. The result is then passed back to the caller as the function's return value. At MCP, tool version equals to 0. Def process data, SDR mode, SDR equals default SDR. Enhanced processing with mode selection. Defines a function named process decorated with @MCP tool and explicitly sets its version to 2. The function accepts a required string parameter data and an optional string parameter mode that defaults to default. It returns a string and includes a docstring describing it as enhanced processing with mode selection. The decorator registers this function as a tool within the FastMCP framework, using the function name as the tool identifier and the docstring as its description. If mode equals reverse. Return data, -1 upper. Checks if the mode is set to reverse, and if true, returns the data string reversed and converted to uppercase. The slice notation, -1 creates a reversed copy of the string, and upper converts all characters to uppercase. FastMCP3's decorator-based versioning system enables seamless API evolution by allowing multiple implementations of the same tool to coexist under a single identifier. The @MCP tool decorator with explicit version parameters registers different versions of the process function, where version 1 handles basic string uppercasing, and version 2 introduces an optional mode parameter for enhanced functionality. The framework automatically manages version selection, exposing the highest version by default while maintaining backward compatibility. This approach follows PEP 440 semantics for version ordering, ensuring predictable resolution. The design enforces a strict requirement to version all components or none, preventing inconsistent filtering behavior and ensuring predictable version resolution. While this pattern facilitates gradual migrations and maintains backward compatibility, it introduces a maintenance burden of supporting multiple versions, which FastMCP mitigates through version filtering and discovery mechanisms. The key insight is that this versioning strategy allows for API evolution without breaking changes, enabling clients to continue using legacy interfaces while newer clients access enhanced functionality.
The decorator births tools, each version a louder echo of the same function, yet none ever answer back.